Hello folks, we are once again back with this integration by parts, and now we are into the question number 19, which says that e raised to x times 1 minus x minus 1 over x minus 1 over x squared. We need to find the integral. For this we need not do, though it is coming under integration by parts, we have learned that we need not do integration by parts. In fact, we use a formula e raised to x times fx minus f dash x. Whenever you have expressions which is of that kind, we know that the integral comes out to e raised to x times f of x. So that's the idea that we are going to use over here. This is of the type e raised to x times 1 over x plus minus 1 over x squared dx. When you carefully look over here, you can check that if you could look at the function f of x as 1 over x and we try to look at the derivative, then derivative we know is x raised to negative 1, which means n x raised to n minus 1. That way it will be negative 1 x raised to minus 2, which is exactly this, minus 1 over x squared. So therefore this expression is of the type e raised to x times fx plus f dash x. It's of that kind. So we know whenever we have an integral of that kind, the integral will always work to e raised to x times f of x. So therefore it becomes really easy for us. It is going to be e raised to x times f of x, which is 1 over x plus c. It's only that much. So because we could understand that it is of the type f of x plus f dash x, we could quickly get the integral, and integral will be like this. So quickly on the same lines, let's move to the next question also. It's very tricky in the exam. It is for us to spot that it is to be falling in this. If at all it doesn't fall into this category, then we have to do integration by parts and get the integral. That's how we do it. The next question, it says that it is x minus 3 over x minus 1 the whole cube, which is whole cube times e raised to x dx. Now here we have to do a little work and show that it is of the type fx plus f dash x, and then apply the integral and get the integral. So let's consider this part alone and see how we can do it like that. So let's consider x minus 3 over x minus 1 the whole cube. The x minus 3, we could always write it as x minus 1 minus 2. We are just breaking up that minus 3 as minus 1 minus 2. Now because of this, we could write it as x minus 1 over x minus 1 the whole cube, and this is 2 over x minus 1 the whole cube. Okay, so this part, it will come to 1 over x minus 1 the whole squared, and here it is 2 over x minus 1 the whole cube, or rather we could write it as plus minus this way. Now this is fair enough for us to find out what is fx and f dash x. If you consider this as f of x, let's check if this comes out like that. If f of x is 1 over x minus 1 raised to 2, which means it is x minus 1 raised to negative 2, and let's look at f dash x. So f dash x will be negative 2 x minus 1 nx raised to n minus 1, so it's going to be negative 3, and because x it's linear over here, so you treat it like x itself. If there is no differential coefficient, so this is what the differential will work out like. Now that means this is negative 2 over x minus 1 raised to 3. So when we try to correspond this is fx and this is f dash x. So therefore you are able to convert this. So let's get back to I once again. I has now become e raised to x times 1 over x minus 1 the whole square plus minus 2 over x minus 1 raised to 3 dx. So the idea is fx plus f dash x. So therefore this will become e raised to x times fx, which is 1 over x minus 1 the whole square plus c. So that is the integral for this one, e raised to x over x minus 1 raised to 2 plus c. That's all for this problem number 2. So that these should be all for this video. With the next problem, we can meet in the next video. Thank you.